Okay, what's up guys? Sorry about that dancing and singing. Anyways, tonight we're continuing one laptop which we've been doing for quite some time now. I think it's been more than a month, if not two. Anyways, it's a Lenovo G50. We were doing this laptop, not particularly this one, but the other board. This one. We did this one up until it was dead. Then we managed to change the super IO, but then still it only goes on, no display. So most likely the super IO didn't match with the board, so we need to get another super IO. So what I've managed to do now is get another motherboard. It's not exactly the same. Actually, it's not the same. Is it? Yeah, it's not the same. Anyways, that's besides the point. The point is this motherboard is also dead, but it's reasonably dead. I don't know if that makes sense, but it's reasonably dead. Anyways, let me get the frame for this. Okay, that's the cable there. So from what I've managed to notice is that we have power only to a certain point. We don't have the main power downs, or if a laptop doesn't have a main power down, the chances of you managing to fix that laptop are a little bit high, because it's all those secondary power downs which are a bit troublesome. Yeah. But the main power is pretty fun to fix, because the main power doesn't usually have chipsets on it. Like, it doesn't really have a chipset that controls it. You might have a chipset which controls charging, or which controls the inrush limiter, but then I think it's only those two which affect the main power, unless it's a MacBook. Yeah, because the MacBook does need a lot, especially if it's the Type-C. Anyways, in this one there will most likely be a dead cap, or it's a dead MOSFET. So it's as simple as that, nothing much. So now I'm going to plug in the charger, and we will measure and see where we are in terms of our voltages. So I'm quite sure you guys would love to see an up-close view of what's going on. Okay, so the song is really good. I keep forgetting that I have to do some work. Anyways, that was the charger, so that's where our DC in is. So we're going to measure our voltage there. Yeah, I'm quite sure that's clear. Okay, so there we go. We do have 19 volts over there, and from over there it seems like it goes through that fuse over there, PF101. So we do have 19 there, and we do have 19 over there. So the fuse is fine. The fuse is fine. Beyond the fuse, we have these two inductors over there, PL708 and PL706. So we do have 19 coming in there, and we do have 19 coming out. From there we come to the first inrush limiter, that's PQ, that will be PQ301. PQ301, and we do have 19 coming in. What we have coming out? We have 19 coming out. So our first inrush limiter is fine. And then on the second inrush limiter, we have 19 coming in. We have nothing coming out. We have 0.88. So that's our problem. That's an issue there. We don't have a main power. So even if we come to the current sense resistor, we have nothing. It's 0.9 volts. This won't do anything to the laptop. We want power on or anything. So let's check for a short circuit in the main power now. We don't have a short circuit. We don't have a short. How much resistance do we have there? Oh, it's not even in the 200 range, it's more like in the 200k. Can't say anything, most likely because my meter is going low on battery there if you check. So the readings there would really be difficult to trust when it comes to resistance. Oh, there we go. Oh, so we do have a lot of resistance there, 16 mega ohms, that's a lot. Really should be in thousands, like maybe 600k. Yeah, I don't trust this guy. Anyways, so since we don't have a main power now, my main suspect is this guy over here, the second inrush limiter. I don't know if you guys can see it, but then the coloring on that there, over there, it's kind of weird. This thing seems like it has been burning. So I'm just gonna change that second inrush limiter there. It's a MOSFET, so I'm sure it won't be much trouble to deal with. Just power on the soldering and the hot air. Then we're gonna take it from this board, because this board we managed to actually make it come on. So that for those that don't remember, let me just show you what we did. I'm just gonna power on this motherboard now. Just get the power button. I don't want to use a tweezer. I don't want to give you a lot of rich. Okay, there we go. So you can take a look at the LEDs over there. They are there. So you can see we actually managed to make this board come on, but then there's no display. So my main suspect was the Super I/O, because that's what we changed since it was burning up. Anyways, now let's deal with this board which we are doing now, our troublesome motherboard. Yeah, we're doing this board. So we want this MOSFET over here. I think I'm gonna make a mistake here. This motherboard. Oh yeah, I'm gonna use the network card, the G50. Okay, it's out of focus now. Okay, so adding a little bit of new solder will make the it'll make it more easy to deal with taking off the MOSFET. Yeah, a water station is fine, it's enough. It's totally enough to deal with this. And then the whole reason why I am using new solder is that my hot air has got a big nozzle. Like the size of this nozzle is too big, so it doesn't target. It doesn't target a small area. Oh, where are you now? Oh, yeah. Let's just move here. Instead of targeting a specific item, it will target multiple targets. But if it was a smaller nozzle, it would target the very MOSFET which I want. So the other thing which might help is to warm the area around first. Just warm the area around so that when you now target on your MOSFET, most of that heat doesn't get distributed to the rest of the board. Now you just focus on the MOSFET which you want. Yeah, come out, you sucker. There we go. And there we go. Nice. Okay, so on this I didn't put any new solder. As I said, I'm gonna work with soldering paste. So if you actually take a look at the MOSFET, when I put soldering paste on it, that area doesn't want to hold any paste. I am pretty confident this MOSFET is dead. We're gonna measure it. I have never done MOSFET measuring before. I've tried, but I didn't trust my multimeter, so yeah, let's try it now. So from there we can see pin number 1 is that one over there. That's our pin number 1. If that's clear, it's not clear at all because of the paste. Yeah, that's pin number 1. So from what you know, if you already know, if you don't know, where the dot is, like over there, that dot, that's pin number 1. So pin number 1, 2 and 3, they are connected together, and then these 4, they are all connected together. But then this one, that's the gate, so it's the one which receives the signal to say MOSFET open the channel, don't open the channel, close, do this, do that. Yeah, so let's try to measure. As you all know, if MOSFET, you measure it along is 3 pins, so yeah, we do have 5 for 1 over there. Let's just activate. Yeah, this MOSFET says it's fine. Dang. I'm quite sure we're gonna need a schematic for this. But anyways, let's first replace the MOSFET. So one might wonder, like, what could happen if we just took a jumper wire or that might work, but I've explained this before. It only works for a motherboard which does not have a controller. So if there is a controller for these MOSFETs, which there most likely is, or rather there always is, that controller is going to be needed. You don't need the signal coming from the MOSFET. Other than it sending the signal to the MOSFET to open the gate, it also needs the signal from the MOSFET. Otherwise a particular signal will be missing and the laptop just won't behave, or might not even come on. Oh no, which just went up. I'm gonna use my fan to rapidly cool this guy down. Yeah, for those that still remember this movie. Yeah, those were our childhood days. We were still children at the time. Anyways, let's check. Did we actually solve the issue? I don't like that. I actually hate a spark. Well, I'm that other guy. I'm just a shy kid, camouflage before your eyes, and I knew my lyrics were the key to see the other side. I should have told you, but I never had the courage, and I thought you really wouldn't understand. Do we now have a main power? Please give me a main power. Oh snap, we don't. Oh, this thing is loose. That thing is loose over there. There's more than 19 rows. Oh, this guy is sick now. Now we're still on the same issue. Okay, so I'm going to pause the video for now and charge this battery, because with the altimeter given those readings, we really can't work with that. In the meantime, I'll also be looking for the schematic diagram. Yeah, I'll also be looking for a schematic diagram so that I can work with the controller, because we already have another motherboard, that one, it's going on, which simply means its controller for this MOSFET is fine. Yeah. So after that, I'll also have to measure the resistance with the battery, which is 5. Because with this, we are just really not working. We are playing. So yeah, that's it for now. Let me just pause the video and charge this battery. Yeah, pause. attached this battery now, so we can continue with work. Yeah, it's been just a few minutes and it's enough. Alright, there we go. We can power on. So where were we? I hope you guys can see that light won't affect your view. Okay, there we go. I think you can see from there. Anyways, I was saying I'm gonna check a short in the main power room because we've just changed this MOSFET, the second MOSFET, and found out that we don't have a short. Okay, anyways, let's check for that shot in the main power. Okay, so that's our second MOSFET which we changed over there. So let's see. We actually don't have a shot. Let's check in resistance mode. Let's increase the range to 200k. Oh, still don't have everything. Let's take that to 20 mega ohms. Are you okay? Okay, so there we go. We actually have 11 mega ohms. We don't have a short definitely there. Let's bring it back. Yeah, we have 11 mega ohms. Yeah, 10 actually. So we don't have a short. We don't have a shot. So what's going on? Let's have a look at the schematic diagram. I think that would help. I'm gonna view it on the phone. It's much quicker than using a laptop. Setting up the laptop would take a lot of time. Anyways, it's to so it's ACLU1/ACLU2 UMA NM A272. Search. Okay. Yeah, I found it. There you go. I'm quite sure you would appreciate seeing where I'm downloading this, so I will record on my phone. There we go, record. Downloads. Okay, so where are we? It's PQ302. PQ302. Oh, there's a controller. PQ301. That will be this guy over here. Okay. Anyways, PQ302. Okay. I didn't even capture it. Okay, so there we have PU301, which is this guy over here. Over there, PU301. Let's go up. It comes actually getting its signal from the resistor before and after. Let's see, we're actually looking for PQ302. That's our MOSFET over there. It's 3 pins, that's obvious. There's 4 pins. Then pin number 4, it's coming from, oh, it's not coming from the chip. It's not controlled by the chip at all. That thing is independent, which could only link to one thing. Let's check for a short in PQ301. Yeah, the reason why I'm saying let's check for a short in PQ301, if PQ301 has got a short, it's just going to let power flow through. It will just let power flow through. So let's check for a short. How many ohms do we have in terms of resistance there? Okay, we have a short. 0.5 ohms is basically an open line. There we have 1 ohm. There we have 0.8. This is a short. So there we go. These 4 pins are connected together. That will be those 4 pins there by the end. And then these 3 pins, which are saying 1, 2, 3, that would be from the dot over there, that would be pin number 1, 2, and 3. It's actually out of place, I think. But it actually works like that. Anyways, that would be pin number 1, 2, 3. As you can see there. So we actually have to take it out. That's our culprit. Let's see what we get. PQ301. How is this thing working? It's off place. And take a look at the one which I placed. Nice and neat. But take a look at this one. This is insane. Okay, let's lift it off the board. No wonder why the first MOSFET which we took out from there, when we were measuring it, PT303, it was saying it's fine. Where is that MOSFET anyway? That threw it away somewhere. Here it is. So let's place this one there now. Instead of throwing this MOSFET away, let's use it. I'm sorry for shaking the microscope. The picture of the song just changed. Okay. These things suck. So you wanna take it off the motherboard, it gives you a huge challenge. Now you wanna put it back, it still gives you a huge challenge. What's wrong with you guys? Yeah, there's a pin that's wrong there. Now I've moved that guy. So one pin is off for this MOSFET. It's actually it's too low. Okay, let's try it again. I was making the other pins not to sit properly. Okay, now we are good. I am just opening it. I don't know if you can see, there is a little dot over there. It corresponds with the white tape there. Let's check for our resistance there. Yeah, we no longer have a shot. It's actually not advisable to make any measurements or to check to even connect a charger when the motherboard is hot. Up on mine. Okay, we are cool now. Let's plug in our charger, see what we get. Go to voltage mode. So we have our 19 volts coming in, 19 volts at the fuse, 19 volts at the MOSFET, 19 after the MOSFET, 19 here. Oh, you guys can't even see that. Okay, I was saying we have 19. Oh shit. We have 19 at the fuse. We have 19 coming into the MOSFET. 19 outside of the MOSFET. 19 there. Oh, now we do have the main bottle. Would you look at that? You now have a main bottle. Let's check it elsewhere. Oh, shit. Let's check for it elsewhere. Okay, so we have a secondary part over there. So let's see. Ah, we have our 19 volts. So let's look for the 5 volts. So as you know, that would be 2 coils which are parallel to each other or opposite each other. In most cases, they would have our 5 volts and our 3.3 volts. And we don't have that. 19. Oh, here we don't have anything. Don't have any output. Nothing. So we don't have 3.3 and 5 volts. It doesn't. Oh shit. Again. We have a dead super arrow. Just like the first motherboard. It's hot. It's burning. Hey, can you see the paste is melting there? This is dead. It's official. Lenovo is a mess. This is my 3rd motherboard now. From the start of this repair for this same person. One dead EC after another. I've just wasted my time. Okay. There's nothing more here, guys. This is a dead EC. Let's just see. Let's just check on the schematic for 3.3. Let's check what are those coils. What are those coils over there? PL3 and PL304. So we're going to look for PL303. 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 PL303 that provides us with 3 volts always. So it's coming from this chip PU904. PU904 would be that one over there. PU904, that will be that one over there. Anyways, what else should we get there? 3 volts always, and 3 volts. That's where we should be getting our 3 VLP. That goes with the Super IO. This one by PJ304 goes to the Super IO. This one. So 3 VL. 3VLP. It goes to our Super I/O. What do we have? PJ304. There is PJ304 over there. PJ304. So let's try to disconnect that. Let's try to disconnect that. Oh, what's going on? This could have worked better with the copper thread. And I'm out of copper threads now. Anyways, what I wanted to do was to cut the power supply to the Super I/O, just to prove that this circuit is shorted by the Super I/O. We didn't even check for a short circuit then. Yeah, we can use resisted mode to see that. Okay. So this guy says he is shorted. And we can show that one as well. Oh yeah, it comes right there. Let's see. What was this guy saying? I'm just going to do some sanity checks before I conclude to say that the Super I/O is damaged, of which it's pretty obvious. It's heating up. There's no other explanation. I'm just going to change this controller, this IC chip. And then after changing it, we can make a full conclusion. Remember, we have a board that's powering on, just no display. So yeah, we can work with that. We can work with that. So let me just take this off from the motherboard. The whole day. Okay, so the chip is off from the motherboard now. What has happened to our shot? And we still have a shot. We still have a shot. Is it a shot or it's just low resistance? 17 ohms. 17 ohms is not a short. It's just low resistance. It's not a short really, it's just low resistance. But this is a short. I'm saying over there, we just took off the board, the chip. There, as you can see, we have 17 ohms. This is not a short. This is low resistance, and yes, it's buzzing. But not because it's a short, it's low resistance. It's the same with the CPU MOSFET. It won't be a short, it will be just low resistance. But then this over there, this is a short. This is a dead short. Let's check with the other board what we have over there. So let's try that resistor there. Nah, it's not a short. And here what we have. So here we actually have 28 more ohms. And does it buzz? It doesn't. It does. So you can see it's not a short. And this motherboard, you know, it's coming one, it just doesn't have a display. So yeah, it's fine. 58 EC, 58 most super IO. That's like this one. So yeah, that's the end of the road for this custom. I have tried my best. More than 3 motherboards now, 4 motherboards actually. Actually, this proves something. Lenovo is crappy. Or at least this series of Lenovo, it's a crap. It's really useless. Because I can't have more than 3 motherboards having the same issue, same problem, all of them. What's the point then at the end of the day? It's really a crap. Because now I've wasted how many things? Anyways, yeah, that's it guys. So what I can do to recap in terms of this repair, which might be of use to someone, let me just highlight what we just did today. I was really excited to fix this because the main part of fix is usually a success. Anyways, so what we discovered is that we didn't have an output there. we had an input but didn't have an output. So some people might be confused to say, why did we have 19 volts all the way through this MOSFET to over there, but we didn't have it out there? Yet our problem was with this MOSFET. Reason being, you see, if you take a look at this, these 4 pins, they are connected together. These 3 pins are connected together, and then this pin is not. Now this pin, what it does is that it receives a signal. It's a gate. It's the one which tells the MOSFET to allow power coming in from these 4 pins through to those 3 pins. So it's the gate which opens the MOSFET. So if the MOSFET is just shorted, if it's dead, it will just allow power to flow through. An entire 19 volts coming through, feeding through. Yeah, so that's the problem. It will just go through. Anyways, so that's the issue. Whether the MOSFET was fine or dead, it would still tell us that it's okay, because we'll be seeing power flowing through. So that was the issue. But when it comes to this, to the second MOSFET, it will be locked because it's in reverse, as you can see. It's in reverse. It's not 3 pins first and then 4 pins. So we need to get a signal first which proves that this MOSFET is fine. If this MOSFET is okay and the signal is okay, then this one will also open and allow power to flow through. So that's the whole reason why we didn't have power flowing through, because this MOSFET wasn't fine. So yeah, so that's it for now, guys. I really hope you guys learned something. Yeah. As for this motherboard, I might as well as quit trying to fix it, because it's costing me motherboard after motherboard. Customer will never pay enough to recover my fees which I've lost on that. Yeah.
Let me talk to you, say a few things. Girl, I'm feeling you, but it's up to you. Say you